All right, good morning, everyone. My name is Kyle Lake. I'm an application engineer with Oasis Sales, and today I will be presenting our webinar, and this is going to be part of our Advanced Tech series, where we will be talking about Xpedition and panelization within the Xpedition Flow. All right, it is just all with Xpedition Flow and how we will panelize your printed circuit board. What we can do within the FabLink and Xpedition Flow is easily create that panel design directly from the PCB. So we'll see that this is always going to be connected directly to your design data. This can be pretty powerful because if you make any changes during any aspect of the PCB design or the panel design, those changes can be reflected automatically and brought into the panel design. So you can do panelization process can be happening while there's some last minute changes happening in the PCB design as well. Okay. So after we talk about that, we'll just talk about how we can array multiple PCBs onto the panel. Xpedition does have the ability to do multi-board panels. And then we can go ahead and run some panel level DRC checks and then generate manufacturing documents. All right, just a little bit about Oasis Sales. If anyone is unfamiliar, Oasis Sales, we are happy to be a Mentor Graphics, now a Siemens company premier partner. We've been with them for over 18 years. We work with many of different Mentor Graphics tools, and we're happy to help our customers understand what capabilities they can gain from different products that we offer, help support them in the pre-sales and post-sales technical effort. Okay, so if you're unfamiliar with Oasis Sales, I'll have my contact information if you have any other questions or need any other info. Down below, you can see the states that we currently service. So if you're in this webinar and you don't see one of those states, you may be working with TriLogic. And TriLogic is kind of our counterpart. They're up in the northeast part of the United States. Again, they have been working in EDA for over 30 years. They are also working with Mentor Graphics, now with the Siemens company, and they're heavily reliant on Omnify PLM for data management as well. So again, if you are in those states down below and need any technical resources on any of the topics that we cover today, or have any interest in learning more about what Mentor Graphics can offer you in the realm of electronic design, please feel free to reach out to them as well. So just a good geographical breakdown of where we cover. Some of you may not be in these highlighted states. So we've got Oasis Sales in the Midwest and Northwest, and again, TriLogic is on the East Coast of the United States. If you're not within that territory, we're still happy to help out with technical resources, as well as point you to the people that you should be talking to. So Oasis Sales, as well as TriLogic, we have partnered together to try and bring up some webinars that are helpful for our customers or prospective customers. And all of those can be found on our YouTube channel. So there's the link for that. Or if you just Google Oasis Sales, you'll be taken to our webpage where you can find all of those webinars on that webpage as well. So the next webinar that I will be hosting, it's going to be a while until Thursday, October 4th. And what I'm going to be covering in that webinar is what is new in the newest version for PADS Professional and Xpedition. So version VX 2.4 will be coming out here in September, and I'm just going to be covering what the new features are in there and highlight how to best use those. So it's going to be the same time, Thursday, October 4th. Here is my contact information in case you'd like to contact me in the future. If you have any questions on what we cover today or would like to get an evaluation license, please maybe take a screenshot of that, write that down, and I'm always happy to answer any questions. Likewise, if you have any questions during the presentation today, there is a chat box that's included. Please feel free to ask questions, and I'll try and get to those if they're relevant to what we're talking about. If not, I will definitely follow up with you after the webinar today. Okay, without further ado, I'm just going to go ahead and get started, hop into our topic today, which again is the panelization process with the Xpedition Flow. So if you're unfamiliar with what Mentor Graphics can offer, here's essentially the four major product family groups in the printed circuit board realm. So what we're going to be talking about today kind of falls in between Xpedition as well as pads. Xpedition being the enterprise PCB design tool for large-scale companies that need a lot of collaboration between groups in different sites, or high-end data management capabilities, or utilizing very high-end technology where they really need the horsepower that's necessary on the layout side. Okay. So also is the pads more of a desktop-based solution. Pads has been around for many years, really a very useful tool that allows you to quickly get designs out. Even if they're high-end designs, you just don't need that wraparound for data management, collaboration between different sites, that kind of thing. So where FabLink will fall into this is Xpedition as well as Pads Professional, if you're familiar with Pads Professional, has the ability to utilize FabLink, which will allow us to do that panelization and create some better manufacturing outlines or manufacturing output. So on the signal integrity and simulation realm, Hyperlink's industry standard tool for analysis and verification of signal integrity, EMI, power integrity effects. We have covered quite a few webinars on that, so if that's of interest, please take a look at our YouTube channel for more information on that. So kind of on the end side of the realm of printed circuit board design is Valor. So Valor NPI is essentially a DFM check as well as an assembly checker to make sure that your board can be both manufactured and assembled with the highest yield possible. Okay. All right, so what we're talking about today is Xpedition Fablink. And here are just a couple of key points to kind of remember on what is important with FabLink. So FabLink is always driven from Xpedition layout. This is a very important feature as it allows us to always be working with the most up-to-date PCB design data that you have. So like I was saying in the beginning, we are able to start that panelization process even if the actual printed circuit board design is not fully completed. Okay, so we can start placing the panel, doing some dimensioning, adding notes, anything else that you need, and then we are able to actually upload all of the new design data, such as component movement changes, manufacturing outline adjustments, new mounting hole locations, or just different routing schemes that will all be uploaded into the new FabLink. So it's always tied to that printed circuit board layout, always reading in that data to make sure that we're working with the most up-to-date data. I did mention that Xpedition Fablink is able to support multiple types of panels. So we can have a single board panel, as in just one type of printed circuit board on the panel. As you'll see in that picture, I've got 9 of that same PCIe type card. We also have the ability to do flip-flop panels where you can have one board on the top side of the panel, and then you can flip it to the back side of the panel. That's a flip-flop panel. Also, we have the ability to do multi-board panels, so you can have multiple types of, multiple designs of printed circuit boards, different projects on the same panel. You do have to be working with the same stack up in between those projects or between those boards, which makes sense because this is all going on the same panel, has to be the same stack up to be manufactured correctly. Okay. All right, I'm not seeing any questions yet. That's totally fine. Just want to make sure everyone knows that that chat box is available if you have any questions. Okay, so what I'm going to be talking about in these slides today is essentially how FabLink is used in the panelization process. So there's 6 major steps to what we need to do in order to correctly output a FabLink manufacturing set. And those steps that I'll be walking through are, first we have to define the panel, make sure everything's set up correctly, and then we're going to go ahead and start adding boards to the panel. Okay, so like I said, we can do those different types of panel. We can do a single board panel, a flip-flop panel, or a multi-board panel if we would like. Next, we can start adding mechanical elements to the panel as well as other elements being thieving, milling data, mechanical elements being fiducials, any other type of shearing hole, sky hooks. We can add those all into the panel. And so where all of those type of mechanical elements and other elements live, those live in the central library that Xpedition utilizes. This is important because we can use those types of elements. You can create a test coupon for all of your 6-layer boards, and that can live in the library. And then that is very easily accessible in any other panel design that you might be doing utilizing that same type of stack up. Okay, so if you create a couple 6-layer coupons that you're going to be using frequently, we can save that into the library. And then every time you are trying to create a 6-layer panel, you can easily grab that coupon and place on the board or on the panel. Okay. So after we've gone ahead and added all of those other elements, including dimensioning, very important in the panelization process, we will go ahead and update that board data, again, making sure that we're working with the most current up-to-date PCB data that we have. And then we will be running panel DRC checks. So FabLink has the ability where we can put in, again, save a scheme of our certain element-to-element clearances that we're checking for our panel. And then we have the ability to run those panel DRCs in order to make sure that there's no major violations that we're running. Finally, we're just going to go ahead and generate that manufacturing output directly out of the FabLink workflow. Okay, so the first 2 steps in that panelization process, first being defining the panel. And what can be important when creating a panel the first time is panel templates. So again, utilizing the central library, we have the ability to work with templates where the template can define the panel outline as well as the panel border and the origin, as well as if you have any fab notes, again, which can be useful on a panel by panel process. We can have those fab notes directly in the template so they come in as soon as you create the panel design. Okay. So after we've gone ahead and actually created or defined that panel, we're going to go ahead and start placing or adding boards to the panel design as well. So you can see that board placement dialog box just to the left. We have quite a few options where we can play around with. So initially we will drive it from Xpedition Layout, and then we'll automatically want to place the board that we're driving with. So you can first point to that PCB file that you want to place on the board, and then go ahead and place that in a panel array, or we can flip it to the other side, or in a certain type of rotation. You can really play around with what you'd like. If you would like, again, you can place different types of boards on that panel. If you'd like as well, you can just point to a different PCB. Okay. So the next steps are probably the most time sensitive or time staking processes, are adding mechanical elements to the panel. So this is going to make sure that we can actually go ahead and make this a fully operational panel in the fabrication process. This includes breakaway tabs, fiducials, sky hooks, test coupons, and then any other types of holes, shearing holes or tool holes that you might want to add to the panel as well. Once we've gone ahead and added those manufacturing elements, we can actually add other elements as well. So we can add dimensioning, detailed views, or zoomed in areas of certain boards just to give a little bit more of an information easily viewable. And then we can also add a drill chart and stack up that again is automatically read from that PCB file and up to date if that stack up may change late in the game. All right, so the last few steps in the panelization process are, again, to update that board data. So we're going to read in that PCB file again, just to make sure we have all of the panel information correct. And then we are going to go ahead and run those panel DRCs. So you'll see on the left-hand side, we've got a matrix system of us defining our DRC checks that we'll be checking. So we can have manufacturing outline to board outline checks, manufacturing outline to fiducials, just to make sure, again, standard type clearance DRCs in order to make sure that we are going to be able to create this panel correctly. So after we run those DRCs, we can change those or fix those errors if we have any, and then we'll go ahead and generate manufacturing output, mainly in the ways of ODB++ or a Gerber output. And then, of course, we can do a printing of a PDF as well to include all of your layer information for easily viewable for anyone in your organization. Okay. All right, so with that, I'm going to go ahead and actually hop into the tool. Again, I don't see any questions from anyone yet, so please feel free to ask any questions if you have those. All right, so this is my layout in Xpedition Layout. So I'm assuming most people here are somewhat familiar with Xpedition. This is a fully done layout right now. I've got all of my planes, all of my unroutes completed. So now we're going to go ahead and start doing that panelization process. Okay, so in order to start that process and kick it over into the FabLink tool, I'm going to go ahead and hit Analysis or Output and hit Xpedition Fablink. So this will start up the Xpedition Fablink tool and start sending all of that our printed circuit board data over into the Fablink tool. Because this is the first time that I've created a panel for this particular design, we're going to see the panel design wizard. Okay, so what's going to be showing here is just the file name, the new file name of our panel, and it typically puts it inside of the PCB directory by default and creates a PNL file, which is our panel file. Again, we're going to be pointing to that central library. The central library holds all of our information as far as coupons go or panel cells, as well as the pad stacks that we'll be placing for fiducials or holes. So I have gone ahead and created a couple of different templates for the types of panels that our organization might be doing. So again, we can have different templates based on the different technology that you have. And what's included in this template is you can have notes, you can have borders, you can have company logos if necessary. You can essentially create anything that you'd like to start off with in your new blank panel design in this template. So I'm going to go ahead and use this 6-layer template and go ahead and click Finish. Okay. So this brings open my panel design. Of course, it's empty right now since we haven't placed any boards. You'll see that we do have some fab notes in the bottom right-hand corner showing those, again, are brought in from our template file, and those can be adjusted on the different template files that we're working with for the different types of technology that we're using. Okay, so very easy process to go ahead and start placing boards into this panel design. So all I have to do is go to the Place drop-down and hit Place Board. This is that board placement dialog box that we saw earlier. Again, I am pointing to that PCB file that I drove this from. I can adjust that to point to a different PCB file, and we can make a multi-board panel here. Okay, so I have a couple of different options here. What I'm going to do is I'm going to make an array of this board. I'm going to make this 3 rows by 3 columns, and then I can specify the clearance between these different boards in the both the columns, the rows, and the columns, the clearance in those directions. So these are probably specifications you're going to be getting from your fab house. I'm just going to go ahead and put in 25 thousandths, both from the rows and columns clearance between those. All right, so you'll see that it's giving me some ghost icons of the boards and what they kind of look like before I place them onto the panel. And I do see John Wester. Yes, John, you can use millimeters. That's not a problem at all. I just have my design units currently set to thousandths. Okay, so you'll see what first comes in the board is the manufacturing outlines, as well as any mounting holes that you have placed on the board. Okay, so currently no other actual circuit information is visible. What I'm going to do is I'm going to go place and upload all that design data. Okay, so once again, this is going to read in all of the data that we have in that printed circuit board file that we're reading from. Okay, so as soon as I do that, upload all of the design data, I see all of the traces, all of the layers, all of the planes, everything that you need to work with here. Okay. So just like in Xpedition, we do have the display control in the FabLink tool as well. Okay, so what this display control can allow us to do is I can come in here and turn off certain objects, such as layer 3, that plane, and layer 4, if I would like to. I can turn all those on, off on the fly. Okay. Same with all of our different actual design objects. If I'd like to turn off all the traces, for example, I can just go ahead and use the visibility selection filter in the display control to turn off all those traces. Okay, so very similar to how Xpedition layout itself feels and works. So I know a lot of people in the panelization process, if we're doing panelization in-house, they like to use tools that kind of figure out, they read in the board dimensions, and then they say how to best place your boards on the panel and allow you to get the maximum yield per panel. Okay, so if you'd like to do that, once you have arrayed the different objects, I can actually go ahead and move this board and change the rotation if I'd like. So if I select the manufacturing outline, you'll see the function keys down here at the bottom. I can do a rotate 90. Oh, it's not going to allow me because I'm a little bit too close to the board. So I can rotate these different boards however you'd like. Also, if you want to, you can go ahead and rotate at uneven angles. So if I want to rotate at 27 degrees, I can just type that in, and it's going to give me a violation. I'm a little too close. Once again, I can try that 27 degrees. There we go. Okay, so you can adjust any rotation that you'd like, and then go ahead and keep going with that panelization process. All right, just like within Xpedition for component placement, I can select on 2 different design objects, right-click, hit align, and if I want to align the top, it's going to go ahead and align these different objects for us. So if you've moved one of these boards and want to get it back in align with these other boards, I can just go ahead and hit align left, right, top, vertically, and it's going to go ahead and make sure everything's aligned for us. All right, so once we have some boards in our panel, I'm going to go ahead and start placing some mechanical elements. First, I'm going to be placing some fiducials. Okay. So when we're placing a fiducial, it's going to be using a pad stack that we have defined once again in the library. These are all living in that central library. So this fiducial that we use here, we can use this again in a future panel design. So what I can do is I can enter in the XY locations if you already have those. And then you can have those arrayed out on the board manually. If I want, I can just go ahead and place these manually in the different sections on the board, and you'll see what that pad stack is reflected. So I do see a question from Bill. Hi, Bill. Are you able to add a manufacturer standard panel? So what we can do, again, is that templates. You can work with your manufacturer to develop a standard. You get the correct stack up, the correct fab notes that they need, any documentation that they would need. But this program does not have the ability to go ahead and automatically adjust and rotate the boards in order to maximize the yield, okay? So that's something that you'll have to figure out yourself, but everything else that you need in order to tailor this to a certain manufacturer, you can definitely add in for if they need a certain type of documentation or tooling holes in a certain location. That can all be built directly into the template. That way, if you're working with manufacturer A, you can use the manufacturer A template and it should be set up and ready to go for them, as opposed to if you need to use manufacturer B, it will have all of those set up for you, but it does not go ahead and create the best panel for you. All right, so the next thing that I'm going to go ahead and do is, after I've gone ahead and added some fiducials here, what I can do is do some dimensioning. Very important to supply as much accurate dimensioning on the panel as possible. So if I open up the dimension parameters, it'll allow us to have 3 different types of dimensioning. Okay, so the first I'm going to be working with is ordinate dimensioning, essentially telling us how far in the X or Y direction we are from 2 different elements. Okay, so there's a lot of different options in here. I'm just going to hit OK. And as soon as I click on the ordinate dimension, we only have one option to place an ordinate dimension. And just like in Xpedition Layout, if I go ahead and click or hold my mouse over the mouse icon, it's going to just showing us how to use that icon. Okay, so the ordinate dimension essentially tells us how far we are from the XY location of the origin. Okay, so there's my origin at the bottom left-hand side of this panel border. And as soon as I start clicking on design objects now, because I am in that ordinate dimension mode, I can just single click on that mounting hole, for example, and it'll show us that we're 42 thousandths away in the Y direction from that origin. So you'll see as soon as I click on like objects, it mirrors that scheme of how far that ordinate dimension is pulled off of that mounting hole. Okay, so that is ordinate dimensions. And again, these are real-time ordinate dimensions. If I update the origin for whatever reason, these dimensions will update as well. Okay, so the next dimension that I'll be using very quickly is the associative dimension. And what this will allow me to do, I'm going to use a stacked dimensioning technique here. So what I can do is I can first select this mount or this fiducial and select the first design object that I want to dimension from. Okay, so that's going to give me an X readout. And then you'll see, so this is the stack dimensioning. I can actually click on this next fiducial and it'll give us that exact same X dimensioning property, and to this last board here on the far right. Okay, so once I've gone ahead and created those dimensions, I can adjust where those are displayed at in order to make this the most easily read. Okay, and again, these can be in any design unit that you'd like. These can be in inches, millimeters, or mils or thousandths like I'm using now. Okay, so I've gone ahead, added some mechanical objects, some dimensioning. We do have the ability to place detailed views, and what that allows us to do is essentially have a blow up of a certain section of your PCB. So if I'd like, I can go to Draw Detailed View, and this will pull open the Draw Detailed View dialog box. Okay, so I'll go ahead and extend this a little bit. So within Xpedition, we have these context-sensitive function keys down at the bottom hand of the screen. So as soon as I did the Draw Detailed View, our function 9 key has changed to Add Rectangle. Okay, so what I can do while I'm drawing this detailed view is I can add a rectangle and just draw it around a certain section of our section on the panel. Okay, so that's created a detailed view of that section of the board. Okay, so that's an analog circuitry section, just in case we wanted some more information on that. I can go ahead and drag this box out here, and it'll actually bring up a larger view of what that section looks like. Okay, so that's a detailed view, and I have a couple of different options that I can do here. If I want to, I can change the scale from a 100% scale to a double magnification. So I'll just hit a 2.0 scale, and it's just going to give us a nice little zoom in of the section of that circuitry. Okay, so I can exit this properties window dialog box, and once that's drawn there, I can go ahead and move that, rotate it, however you'd like to work with that. Also, if you want to change what that detailed view is looking at, in real time, I actually have the ability to go ahead and move this square over to this section of the PCB in that panel, and it's going to automatically update that detailed view. So what we can do with that detailed view is we actually have the ability to have that on our output, our PDF output. Really can be helpful for some design review of certain sections of your board. So I do see a question from Thomas. And so will the board supplier use your stepped artwork, or will they have to regenerate the array after they have verified all of their manufacturing requirements? That's a very good question, Thomas. And again, I think if you have a good relationship with the manufacturer and you work with them to help develop kind of what your placement standards are, your clearance standards, then they should be able to use your panel file here exactly how you have it viewed. Okay, so it should work. If you work with them to develop those standards correctly, they should be able to take this panel design and just go ahead and manufacture it from there. Okay. All right, so we've gone ahead and actually created some panel, some dimensions, a detailed view. What we can do next is, again, add some other of those elements that are kind of necessary in order to make sure that this is manufactured correctly. So just like in Xpedition layout, we have the display control. Okay, so the display control, the Component Explorer. The Component Explorer allows us to place different types of objects in the layout tool. You can place components, you can place drawings, anything that you have saved in that central library. In this, for example, what I'm going to do is I'm going to go ahead and place a panel cell. So first what I need to do is I'm going to go ahead and just grab that panel cell and bring it into my design here. Once I have that panel cell, I'm actually able to view what that looks like. Okay. So if I'd want, I can go ahead and place this on the board here. So this is just a very, very simple test coupon with 4 through-hole vias, essentially, in order to make sure that the stack up is designed correctly. Okay, so you can place different boards as well if you'd like I was saying earlier. Some people do that for their coupons as well, a small board. Again, it has to have the exact same stack up in order to be brought into this panel design correctly. All right, so what we need to do to go ahead and finish this off is, if I want, I can place the layer stack up. Okay, so again, if I go to the place and layer stack up, what this will do, it's going to read in all of that stack up information again from the board that we have synced into this panel design. All right. Okay. So let's kind of put it in this ugly mauve type color. And in the display control, we can search for different things. Again, if you did not know this, I can just click right where my cursor is right now and start typing. If I type in stack up, for example, we'll see that that stack up for all layers is checked right now. If I turn that off, it'll go away. If I click on the color icon for there, I can very easily adjust the color to make that much, much easier to read. Okay, so this brings in all that stack up information that we had in that printed circuit board, how it's actually defined in here. Okay, so what I want to do next is I want to create a drill chart. And again, we have the tools to automate this process. If I just go ahead and hit output NC drill, what this will do, it's going to go ahead and generate the drill chart for us. We have a lot of different options in here. I can change the drill machine format, the output directory, and the type of sequence that it's working with. I can change the symbols if you'd like. You can just adjust those drill chart settings as you see fit. And like most things within Xpedition, you have the ability to create a scheme for here and then go ahead and use that in designs in the future. All right, so there's our drill chart. Again, you'll see that it's automatically reading in all of this data that we have directly from the panel design that we have in here. So we'll see that this round hole, 30 mils right here, this quantity of 12,843 defined in this panel design currently. All right. Okay, so once we've gone ahead and actually created this panel, now we can run some panel-specific DRCs. Again, to do this, I'm going to go to Analysis and go to the Panel DRC. Right now, we currently have no actual specifications for our clearance values that we want. Again, I'm going to load a scheme that I have saved, and we'll see that it's named Panel DRC. As soon as I click on this, we will see that a bunch of our clearances actually are automatically filled in. Okay, so I've got some just very basic 100 mil, 50 mil, 10 mil clearance rules that we want to work with. Okay, so once I hit OK, I'm going to run a DRC for us. Run that panel DRC. And what this does is it outputs a text file with all of our errors. Just like within Xpedition Layout and PADS Professional Layout, we have a Hazard Explorer. So if I click on this yellow icon, this is the Hazard Explorer. And what the Hazard Explorer will do is there's a couple of different tabs. I've got Online DRC as well as Batch DRC. Okay. So it looks like it only found a couple of proximity errors. And what I've got here is it gives you all of the information on those different DRC errors that you have. So we've got manufacturing to board outline. And if you click on this and have a fit selected, this will actually show us where those violations are happening. Okay. So this looks like in the printed circuit board design, the manufacturing outline was directly on top of the board outline, so we're not getting a clearance whatsoever in that. So what we can do to fix this is we can either go back into the layout, adjust how that manufacturing outline fits around our board outline, or we can adjust these tolerances of that panel DRC to fix these errors. All right, so once we're ready to do some output of manufacturing data, we've got a couple of different options here. So we can output standard Gerber files, and this is exactly how it appears in Xpedition and PADS Professional Layout. This is the exact same Gerber output. So if you're comfortable with that, this is the exact same type of process. We can take a look and see our different files that we have defined for Gerber, as well as take a look at each single file one at a time and see what's going to be output in that Gerber file. Okay. And again, we have the ability to create a setup file and load that in future designs. All right. As well as we have the ability to do ODB++. I'm sure at least a few of you today are using ODB++. That's definitely gaining more traction and becoming more and more popular as a manufacturing acceptable data format. All right, and the last thing I'll show here is we have the ability to do printing. So an extended print, if you go File, Print, Extended Print in FabLink as well as Xpedition Layout, the extended print dialog box will show up. And what this will allow us to do is actually go ahead and create smart PDFs to be very easily created all in one go. Okay, so you'll see here I've got, I think, 8 sheets. I've got all layers on the first sheet, the manufacturing outline on the second sheet, and then the different respective layers on the subsequent sheets. Okay. Again, I can go and take a look at all of my sheets that I had to find for this extended print setup file, and then see all of our different design objects that we have for that particular layer. And once I actually do the output, I have ran that a little bit forward previously. It takes a minute or two to run. We can see that this is our extended print. It can be very useful to have. It has that detailed view. You can tell which detailed view to be working with. And then if you're using Adobe Acrobat, we can have a smart PDF style where I can click on the different links and it'll take me to those different sheets that are in this PDF. All right. Okay, so that is all I had planned to show today. I do see a couple questions that I'll be following up with. If you have any other questions, please put those in now here. And I do see, can you add a sheet format to the panel? Yes, you can. You can have a sheet format for that extended print or the Gerbers or the ODB++. Again, we can have all those setup files saved locally with the design in the installation directory or where your company would like to fit those. So yep, we can have that type of template set up. All right, so that's all I had planned for today. Again, I would like to point out to save the date for my next webinar that I'll be presenting, and that is for PADS Professional and Xpedition, what's new in VX.2.4. That's the newest version that's going to be coming out here in a few weeks in mid-September. And this webinar is going to be on Thursday, October 4th. So if you do get the chance, maybe download that VX2.4, and then we'll be talking about what you can do to utilize those new features and bug fixes that'll be coming out with that. All right. Again, here's my contact information. If you have any other further questions or would like to talk more about Panelization, FabLink, or any other Mentor graphics offering, please feel free to contact me and I'd be happy to help. All right. Thank you, everyone, again for attending, and I hope you have a good rest of your day.